So write down next concept, tension force in a string. So write down some basic points. So first point is it is quite practical. It is quite practical that we can pull an object. We can pull an object by a string. So it is quite practical that we can pull an object by a string, but we cannot push an object. We cannot push an object with a string. So for example, we have an object. Now this object can be pulled with the help of a string. So this object can be pulled with the help of a string. But if we have an object, now this object cannot push cannot push with the help of the string. Okay, so an object can be pulled with the help of a string, but so pushing an object with the help of string not possible. Right on. That means that means it tells us that string can pull string can pull but cannot push. String can pull but cannot push. So it is the first point. So regarding tension force in the string. So first of all, what is the basic meaning of string? So it is quite practical that any object can be pulled. Any object can be pulled with the help of a string, but we cannot push the object with a string. So pulling is possible with a string, but pushing the object with a string not possible. That means it tells us that the string can pull the object but cannot push the object. Second point. So for example, we have a body or an object of mass m, an object of mass m. So a string is a tied. Okay, so it is a tied point. It is the tied point. A string is a tied. A string is a tied to the object. No, it is a free end of the string. It is free end of the string. At this free end of the string, we are applying force. At the free end of the string, we are applying force. So when the force is applied, then in the string, one type of force will be developed. Okay, so this is the object and it is a string. In the case of string, one end point is tied to the object. One end tied to the object. It is a free end. At a free end, we applied a force. At a free end, we applied a force. So is acting, when the force is acting at the end of the string, then some one type of force will be developed. So one type of force will be developed in the string. The force is nothing but tension force. Now the tension force will be developed only when the string is stretched. The tension force will be developed only when the string is stretched. Okay, write down second point. Draw the figure. Draw the figure. If force is applied, if force is applied at the end of the string, if force is applied at the end of the string, force is applied at the end of the string, then a force develops, a force develops in the string, a force develops in the string. This force is called, this force is called tension force in the string. This force is called tension force in the string. Okay, same point continuation. Same second point continuation. Tension force in the string, tension force in the string is present, tension force in the string is present only when string is stretched. Tension force in the string is present only when string is stretched. Okay, next the third point. So the same figure, from the same figure, when the force is applied, when the force is applied, now string becomes taut. Okay, when the force is applied, now string becomes taut or a string is slackened. So what is the case? When the force is applied, when the force is applied, this string becomes taut or a string becomes slackened. So string becomes taut. Okay, that means this tension force is present only when string is taut. When a string is slackened, when the string is slackened, no tension force is present. Okay, tension force in the string is present only when string is taut. Okay, taut means tightness, stiffness. Okay, tightness, stiffness. Okay, so tension force in the string is present. So generally taut means stiffness, tightness will be present. So that is the meaning of taut. And slackened means loose. Slackened means loose. Okay, write down third point. Tension force in the string is present. Tension force in the string is present. Tension force in the string is present only when string is taut. Only when string is taut. Same point continuation. Tension force is 0. Tension force is 0 when the string becomes slackened. When the string becomes slackened. Next, fourth point. See, generally, string always can apply pulling force. String always can apply pulling force. That means tension force is always pulling force. Okay, string never push the object. String never push the object. String always pull the object. String always pulls the object. So tension force always pulling force. Tension force never be pushing force. So why? Because tension force is developed in the string. Tension force is developed in the string. String can pull the object, cannot push the object. In the same way, tension force can pull the object but cannot push the object. So therefore, what is the nature of tension force? What is the nature of tension force? Tension force is always pulling force. Right on? Next point. Tension force. Tension force is always a pulling force. Tension force always a pulling force. Tension force always a pulling force. Next, fifth point. Next point. Write down. There are some important points. There are some important points. There are some important points to remember. To remember about tension force in the string. About tension force in the string. Tension force in the string. Now these points are very important for numericals. For solving numericals, these points are very important. The previous points are simply theoretical, basic points, but to solve numericals, so these are the important points. Write down first one, point number A, direction of tension force. Direction of tension force is always direction of tension force is always direction of tension force is always acting away from the object, acting away from the object, or acting away from acting away from acting away from tied points, acting away from tied points along the string, along the string. So it is about the direction of tension force. So what is the direction of tension force? Tension force is always acting away from the object, acting away from the object along the string. So it is the direction of tension force. Second point B. In the case of ideal string, in the case of ideal string, so already I told you about ideal string. So what is the meaning of ideal string? One is massless. You please refer the last concept. We done already about ideal string characteristics. So ideal string means massless, inextensible, massless, inextensible. So it means that total length of the string is always constant. So the meaning of inextensible, it means that the total length of the string is always constant. The distance between any 2 points, the distance between any 2 points is always constant. So it is the meaning of inextensible. Okay, so ideal string means massless string and inextensible. Okay, so you please answer. I have a question. If in the case of ideal string, massless string, if it is massless, then what is the resultant force acting on the string?
Zero.
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 So keep the point in the mind. Massless means resultant force is zero. And what is the meaning of inextensible? Total length is always constant. That means no elongation, okay, no compression takes place. So that is the meaning of inextensible. Okay, so write down. In the case of ideal string, tension force at all points, tension force at all points along the string, tension force at all points along the string is constant. In the case of ideal string, tension force at all points along the string is constant. So these two are the important points. So in the numericals, we have to follow both points. So accordingly, we have to draw free body diagram. We have to indicate the direction of tension force, everything. Okay. See, first point, what is the direction of tension force? Tension force is always acting away from the body. Away from the body is nothing but indirectly pulling force or the pushing force.
Pulling.
Pulling force.
Okay, acting away from the body, it means that pulling force. Okay, so that is the first point. Direction of tension force is always acting away from the object along the string. Now second one is, in the case of ideal string means massless string. In the case of ideal string, so tension force is the same at all points. For example, if the string is not ideal, if the string is not ideal, string has some mass present, no tension force at all points will be same or different at a different point.
Different.
Right down. Third point. If the string, if the string is not ideal, okay, in bracket, mass of the string is given. In bracket, mass of the string is given. Mass of the string is given. Okay, in bracket, mass of the string is given. Then tension force is different. Tension force is different at different points, at different points along the string. Tension force is different at different points along the string. So we practice both type of questions. So we practice some questions depends upon massless string, and we practice some questions depends upon if mass of the string is given. We practice both type of questions. So it is a basic theory about tension force. Only these points.
I have a doubt.
Please.
Sir, due to tension force, sir, can the string break?
So I told ideal characteristics means. Okay, so what is the force we are applying? What is the force we are applying? Those are under elastic conditions. Okay.
Okay.
Okay, so
No,
we are
sir,
not
I'm
giving.
asking generally.
Generally, your question is clear, but generally, what is the force we are giving that should be under elastic limits?
Elastic limits. Okay.
Correct.
Okay.
Yeah. Write down example. First example. Write down first question. Means first example. Write down. I'm taking it is a smooth surface. It is the object M2. It is object M1. Object M2, object M1. Now these two objects are connected by a string. These two objects are connected by a string. So if it is the ideal string, if it is ideal string. Now what is the tension force at all points along the string?
Constant.
Constant.
So this tension force in the string, let it be T. Tension force in the string, let it be T. Then after, so force is applied. Force is applied. So write down first question. Okay, I have one more thing. When the force is applied, now string becomes taut or slackened.
Taut.
Thought.
When the string is taut, then tension force will be developed or not?
Developed.
Developed.
Doubled up.
So I have one more question. So for example, if the force is applied, this block starts moving with acceleration A. Okay, when the force is applied, this block starts moving with acceleration A. So for example, if we have any object, for example, I have one object. Now this object is moving with velocity V. This object is moving with velocity V. That means any point of the object is moving with the same magnitude of velocity or different magnitudes of
Same.
Same.
Okay, so if this block is moving with acceleration A, that means any point of the object M1, is moving with the same acceleration or not?
Yes.
That means here, now this point of the object, if the block is moving with acceleration A, so any point of the block is moving with the same acceleration. That means what about this point of the block also possess the same acceleration in the same direction or not?
Yes.
Yes.
Okay, now if this point is moving, okay, don't draw the figure. If this point is moving with the same magnitude of acceleration in the same direction, now this point is connected to the string. Now what about the string also starts moving with the same magnitude of acceleration in the same direction or not?
Yes, sir.
Okay, now
Yes, sir.
this point of the block is moving with acceleration A in the same direction. The same point also connected to the string. So now this end of the string also possesses the same magnitude of acceleration in the same direction. Now what about this point of the string also possesses the same acceleration magnitude in the same direction or not?
Yes. Yes, sir.
Okay, now this point also moving with the same acceleration, this point also moving with the same acceleration, this point also moving with the same acceleration. Finally here, this point of the string also moving with the same magnitude in the same direction or not?
Yes.
Okay, now this point also moving with the same magnitude in the same direction. Now this point is connected to the other block. This point is connected to other block. Now this point of this string is moving with acceleration A. That means, so this point of the block will move with the same acceleration or not?
Yes.
Yes,
Yes.
sir.
If
Yes.
this point of the block is moving with the same acceleration A, then any point of the block will move with the same acceleration or not?
Yes,
Yes,
sir.
sir.
So that means my final conclusion is, when the force is applied, these two blocks are moving together with the same magnitude of acceleration in the same direction or not?
Yes.
Yes,
This
sir.
block is moving with acceleration A to right hand side. Finally, this block also possesses the same magnitude of acceleration in the same direction. Okay, that means when the force is applied, when the string is taut, these two blocks are moving together with the same magnitude of acceleration in the same direction. So is the logic clear? The whole mechanism?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so simply here, as for numericals, no, you please note down this block of mass m2, then after this block of mass m1, and we are taking smooth surface, and all the cases again we repeat when the surface is rough in the next chapter, friction chapter. The same question again will be repeated. Okay,
Okay, sir.
yeah. Now it is the applied force. Now m1 and m2 are connected by the string. In this string, for example, tension force T. Now the two blocks, they move together with same acceleration A. The two blocks, they move together they move together with the same acceleration A. The question is, first one, find acceleration A. Second question, find tension force in the string. Find tension force in the string. These two questions we have to find out. This acceleration, tension force, we have to find out. Okay, now let us see free body diagram. If it is M1, and I have one more question. Now in this case, this block is moving along X direction, correct? This block is
Yes,
moving
sir.
horizontally. So if this block is moving horizontally means vertical forces are balanced or not.
Yes, sir.
So therefore, in the free body diagram, no need to represent the vertical forces. Why? Because the motion is along horizontal direction. The motion is along horizontal direction. Only you focus on the horizontal forces. That's it. Focus on the horizontal forces. If it is M1, on M1, what is the applied force? F.
F.
It is applied force. Then if this is the object I'm taking, for this object, what is the direction of tension force? It is a string. So how to draw the direction of tension force with respect to M1? Now M1 is the object we are taking. Now what is the direction of tension force? You try to recall what is the direction of tension force.
Away from the object.
Away from the tide point.
From the tide
Okay.
point.
Correct. Always away from the object along the string. Okay. If this is the object, away from the object. Now
Left
it is
side.
away from the object. It is away from the object. It is away from the object. It is away from the object. But do we have any string over here? Do we have any string over here? Do we
No.
have any string over here?
No.
No. So directly out of these are four. What is the correct representation
Left.
of tension?
Left
Left.
side.
Left side. Perfect. Now it is the tension force. Now this block is moving to right hand side. So what is the direction of motion? Right hand side. Direction of motion, right hand side. Then after, in the case of the block M2. So on the block M2, do we have any applied forces? On the block M2, do we have any applied forces?
No.
No.
So
No. With respect to M2, what is the direction of tension force? If this is the object,
Rightwards.
rightwards. Perfect. It is the direction of tension force. Okay, so tension force always acts away from the object along the string. Now this tension force, same or different?
Same.
Same. Because what type of string we are taking?
Ideal string.
ideal string.
In the question, it is mentioned or not mentioned, always we have to assume as ideal string. In the case of ideal string, tension force at all points will be same.
Same.
For example, maybe you have a question. If tension forces are different, I'm taking ideal string. If tension forces are different at different points, if tension forces are different, definitely the string may elongate, may compress or not.
Yes, sir. Yes,
Tension
sir.
forces are different
Yes,
at
sir.
different points. Definitely it leads maybe elongation of the string or compression of the string. But one of the character of ideal string is it never elongates.
Elongates.
It never compress. That means what is the tension force at all points along the string
Same.
is same.
Same.
Okay. Then after, for M2, what is the direction of motion? EA. That means on M1, how many driving forces are acting? F and T.
2.
Okay, these two are the driving forces and resultant motion EA. On M2, how many driving forces?
1.
Only
One.
one. So because of this driving force, the object M2 is in motion. Because of this driving force, the object M2 is in motion. Okay, is it clear? Both FBDs.
Yes, sir.
sir.
Yes, sir.
Now in the case of M1, I'm writing the dynamic equation, means resultant force. Dynamic equation. So totally two forces acting in opposite direction. It is the direction of motion. Resultant force
F
F
minus
minus
T.
T. Perfect. F minus T. Resultant force means mass into acceleration. That is M1 acceleration A equal to F minus T. First equation. So coming to M2. So what is the dynamic equation in the case of M2? Means what is resultant force?
T.
T. Only one force acting. So resultant force is only driving force T. Resultant force means mass into acceleration. Mass is m2 into acceleration a equal to T. Okay, equation number 2. For example, if we add both equations 1 and 2, okay, we are adding both equations 1 and 2. See, left side addition m1a plus m2a, left side addition. Then after right hand side addition is f minus t, right hand side of equation 1 plus right hand side of equation 2 t. So it is the meaning of equation 1 plus equation 2 minus t plus t cancel out. Therefore, you take a
F
common.
upon m1 plus m2.
Perfect. So you take a common equal to f. Therefore, the first question we have to find acceleration. Therefore, acceleration equal to f upon m1 plus m2. Is it clear, this question?
Answer tension
Yes,
force
sir.
is m2
Yes,
F
sir.
upon m1 plus m2.
Perfect. Now, first question completed. Now, we have to find the second question, tension force. To find tension force, simply you take second equation. We have to find the tension force. You follow second equation. T equal to m2a. Therefore, T equal to m2. In the place of acceleration, the value already we have, that is F upon m1 plus m2. So it is the value of tension force in the string. Now write down the simple shortcut, short trick. Note it down all the points.
So 1 minute, please.
1
Okay.
minute,
1
sir,
minute.
please.
So I have a doubt.
Please.
So you told that because the object is moving in a horizontal path, so
Okay.
the vertical forces will be ignored, right?
Balanced, not ignored, balanced.
Yeah, balance. But the string is also in touch with the object, right? So will not there be any normal force with respect
See,
to the
generally,
point of string?
tension force is one type of normal force only, one type of contact force only. Okay.
Okay. Yes.
Sir, so in this diagram, sir, M2 is acting as a resistance to M1. Can we say that?
No. So in this case, no resistance at all. But in this case, when the force is applied, string becomes a taut. When the string becomes a taut, tension force comes into picture. When tension force comes into picture, the tension force behaves like driving force for M2. Correct?
Okay.
The source is applied force. When the force is up,
Okay.
for example, if force is not applied, string becomes a taut or slackened. If no force
It is
applied,
slackened.
it is slackened. If it is slackened, then any tension force will be present.
Zero
No.
tension force.
No.
No tension force. But when the force is applied, then string becomes a taut. String becomes a taut. Tension force comes into picture. The tension force acting like driving force for M2 to move along with M1.
Okay.
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 Done.
Yes, sir.
Okay.
Done.
Write down. Short trick. So what is the short trick to find the acceleration? Acceleration equal to, so in such type of questions, write down acceleration equal to resultant applied force upon sigma m is sum of the masses. Sigma m, sum of the masses.
Sir, in all sums, we can use this formula.
Yeah, all string type of questions. Okay,
Yes, sir. Thank you.
write down.
Sir,
Please.
so if the string has mass,
I will do it. I will do it. That also I will do it.
okay, sir.
Ah. No, write down second question. So it is a homework question. You try it as a homework. If this block mass M2, and this block mass M1. Now it is the force applied. So as per our convenience, you take this direction is the positive direction so that we won't get any negative signs. Okay, this direction is the positive direction you follow. So it is the applied force. M1, M2 are connected by a string. In this string, tension force T. In this string, tension force T. Now, due to applied force, M1 and M2 blocks, they move together with the same acceleration to right side, to left side,
Left.
Right.
to left side with the same acceleration. Now, question is, you have to find out acceleration. And second question is, you have to find out tension force in the string. Done?
Sir, will
1 minute.
it
1 minute, sir.
the last one?
Sorry, I'm not getting. Sorry.
Or will it be the same as the last question?
No, acceleration same, but tension force will be different. In the last question, force applied on M1. Now in this question, force applied on M2. Okay.
Tension force is equal to F into M1 upon M1 plus M2.
Perfect. Yeah, write down. Next example. It is a body of mass, for example, 3 kg, and it is a block of mass, for example, 5 kg, 5 kg. Now my question is here, we applied a force of 24 newtons, and here we applied a force of 8 newtons. So two applied forces we have, two applied forces. Now these two blocks are connected by same string. In this string, tension force T. In this string, tension force T. So you think logically, one side 24 Newton, other side 8 Newton. Now this system of blocks, will move to right hand side, to left hand side,
Right.
Right hand side.
Right-hand side.
to right hand side with the same acceleration. With the same acceleration, A. Now let us find out acceleration and tension force. So what is the short trick to find the acceleration? Resultant applied force upon sum of the masses. What is the resultant applied force? 32
16.
or 16 newtons?
24 minus 8.
24 minus
Perfect.
8
24 minus 8. So 16 newtons upon
upon 8.
sum of the masses 8.
So
Therefore,
2.
2 meter per second square. Now, second question, we have to find the tension force. To find tension force, that's up to you. Taking 5 kg block, 3 kg block, that's up to you. You take any one of the block. For example, I'm taking 5 kg block. If I'm taking 5 kg block, on this 5 kg block, what is the applied force is 24.
20.
And for 5 kg block, what is the direction of tension force in the string?
Leftwards.
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 And what is the direction of motion?
Rightwards.
Rightwards. So totally how many forces are acting on the block?
2.
Then what is the dynamic equation? Resultant force equal to
24 Newton minus T.
24
Perfect.
minus T.
24 minus T. Resultant force
MA.
means mass into acceleration. Mass 5 kg, acceleration 2. Okay. Mass 5
N.
kg block, acceleration 2 equal to 24 minus T. By simplifying, what we get T equal to 14 newtons. Even though, for example, if we take 3 kg block, so we get the same tension force. Let us verify it. It is 3 kg block. On 3 kg block, it is the applied force 8 newtons. On 3 kg block, applied force 8 Newton. For 3 kg block, what is the direction of tension force?
Rightward.
Rightwards. And what is the direction of motion? Rightwards.
Rightward.
Acceleration already we have 2 meter per second square.
Second square.
Now what is
T
the
minus
dynamic?
8.
Perfect. T minus 8
minus
is the dynamic equation. A resultant force means mass into acceleration.
3 into 2, 6.
So 3 into 2, 6
6.
equal to T minus 8. So minus 8 becomes plus. Therefore
14.
T equal to
14.
14 newtons. Okay. To find the tension of force, that's up to you. Taking this block or this block, that's up to you. Okay. Done.
Wait a minute.
No, sir, 1 minute, sir.
Done, sir.
Okay. Write down next the fourth example. So it is a block of mass M3. It is a block of mass M2, and it is a block of mass M1. So it is applied force. It is applied force, and the surface is a smooth. Now, due to applied force, all the blocks they together move with same acceleration or different acceleration.
Same.
Same. So this block will move with acceleration A. This block will move with acceleration A. This block will move with the same acceleration A. But so here M1, M2 are connected by a string. M2, M3 are connected by a string. For example, in this string, tension force, let it be T1. In this string, tension force, let it be T1. In this string, tension force, let it be T2. Now we have to find the acceleration, we have to find the T1, and we have to find the T2. So totally 3 questions. In this string, tension force T1. In this string, tension force T2. First of all, by using short trick, how to find the acceleration? Only one applied force.
Force applied upon mass sum.
Force applied upon
M1 plus M2 plus M3.
M1 plus M2 plus M3. So first question completed. So to find a T1, for example, I'm taking the block M1. To find a T1, I'm taking block M1. Let us draw free body diagram. For M1, it is the applied force. Then after, for M1, what is the direction of tension force?
Leftwards.
Leftwards. That is T1 or T2?
T1.
T1. And what is the direction of motion of M1? Right hand
Rightwards.
side. Therefore, what is the dynamic equation? Resultant force equal to
F applied minus T1.
F applied minus T1. Resultant force means mass into acceleration. Mass is M1 and acceleration already we have. So in the place of acceleration, I'm writing F applied upon sum of the masses M1 plus M2 plus M3. So it is the left side value, resultant force, equal to on right hand side F applied minus T1. Now we have to find a T1. To find a T1, let us modify this equation. So from this equation, I'm writing T1 equal to F applied minus M1 into F applied upon M1 plus M2 plus M3. So what is the common here we have?
F applied.
So T1 equal to F applied is a common. Now in brackets we have 1 minus M1 upon M1 plus M2 plus M3. and we can simplify it. Now you got the procedure how to find a T1 tension force?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Then after, to find a T2, that's up to you taking M2 or M3, that's up to you. But if we take M3, if I'm taking M3, so why M3 we have to take? On M3, totally how many driving forces
Only one
we have?
force.
Only one.
Only one.
Only one
A
force.
simplification is much easier. Okay, that's why you take M3 block to find a T2 tension force. On M3 block, what is the driving force? Is a tension force T1 or T2?
T2.
T2. And what is the direction?
Right
Away
side.
from M3.
Rightwards.
Right.
So it is the direction of T2. Okay. And what is the direction of motion? Right hand side. Therefore, now what is the value of resultant force? Is
T2.
only T2. Resultant force means mass M3 into acceleration. Therefore, T2 equal to, in the place of
M.
resultant force, mass into acceleration. So M3
M3
in the
F
place
applied divided by M1 plus M2
divided by
plus
M1 plus M2 plus M3. Now this is a procedure we have to follow the tension forces T1 and T2.
Sir, if we had taken M2, then instead of M1 over here in the T1 force, it will come M2, right?
In the case of M2, T1 will be present, T2 also present.
Yeah, okay. Achha.
Okay, so one side T1 force, other side T2 force, both we have to write. Okay, is it clear?
Yes.
Yes, sir.
Okay, yeah, write down.
So wait a minute.
So it is a homework question. So in the question, M1 mass 10 kg and M2 mass 20 kg, M3 mass 30 kg, and applied force 60 newtons. Applied force 60 newtons. Applied force 60 newtons. Same thing, find acceleration, find T1, find T2. Find acceleration, find T1, and to find T2. So I have a question. I got a question from Amog. Let us see the question. It is completed.
So 1 minute.
No, sir, please, 1
So
minute.
just 1 minute,
What is
please.
the motion of the objects, right or left? The
See the applied force, na?
so the acceleration also towards right?
Correct. So it is only applied force we have. Na? It is smooth surface. If a smooth surface, no friction at all. No friction at all. So even though a small applied force is given, automatically the blocks, they come into motion towards right hand side. Okay.
Yes, sir.
For example, if friction is present, this applied force, it has to overcome the frictional force. Then only the objects, they come into motion, correct? If friction is present, this applied force, it has to overcome the frictional force. then only the blocks they come into motion. But here there is no friction at all. It is perfectly smooth surface. So even though a small force is applied, automatically the blocks they come into motion. Okay. Okay. So why to take direction of tension force away from the object? So Amog, he is asking why to take direction of tension force away from the object. I have a question. For example, it is ideal string. It is ideal string, and you know the meaning of ideal string: massless and inextensible. Inextensible means total length of the string always constant. Inextensible, okay, and massless is the meaning of ideal string. And here, for example, a body of mass m suspended from it. A body of mass m suspended from it. Now you please answer, if mass m is suspended, and what is the weight? What is the weight? Mg. And what is the direction of weight?
Vertically downwards.
So this mg vertically downwards. Okay, that means because of weight, because of gravitational force. Okay, so this gravitational force, it is trying, this gravitational force, it is trying to pull this object downwards, correct? This gravitational force, it is trying to pull this object downwards. For example, if this object will move downwards, it is a support point, point of support. Okay, so because of gravitational force, if this block will move down, now what about the string? Will elongate or not?
Yes.
But in the case of ideal string, in the case of ideal string, it does not elongate.
No.
So that means here, to overcome, so it has to maintain the total length as a constant. Ideal string, so total length should be constant. But if it is the only force present, if it is the only force present, definitely because of this force, this block will move downwards. Now string will elongate, but it is the ideal string. String never elongate. Then what will be happen immediately here in the string? One tension force will be developed. The tension force, okay, it tries to oppose this mg. Mg it tries to pull the block downwards. Okay, if it is only mg present, definitely here this block will move downwards. Now string will elongate or not, if it is only force present.
Yes, sir.
Yes, sir.
But if it is only force present, now this gravitational force will pull the body downwards. When it moves downwards, the string will elongate, but it is an ideal string, it never elongate. So that means here in the string we require one force, that the force it has to overcome this mg. Okay, for example, if I'm taking tension force in this direction, okay, if tension force acting on this object in this direction, if this tension force and mg are equal, if tension force and mg are equal, now string will be at equilibrium or not?
Yes, sir.
Yes.
Okay, so if tension force is present in this direction, then only the string doesn't elongate. Only in this condition. In this condition, okay, the string doesn't elongate. So therefore, if this is an object,
Can you give break?
you go out of the class, not an issue.
No, sir, please continue.
So if this is the object, now what is the direction of tension force? Towards the object or away from the object?
Away.
Away from the object along the string. Got it?
Yes, sir.
Yes.
So that's why, because of the reason to keep the length of the string constant, we have to take direction of tension force, okay, away from the object along the string. Okay. Yeah, write down. Next question.
Sir, we are having lecture from 8.
So I do have lectures from 8. See, generally you are sitting in the class, you are listening, not listening, writing, not writing, God knows. But as a faculty, we have to pay each and every minute more attention. So you will be more stressed, or as a faculty will be more stressed. You no need to speak. You're writing, not writing, you know very well. But every minute, the faculty, we have to pay more attention. So we have to feel more stress, but we are ready to give the content. Then what's the difficulty to you? Yeah. Next question. For example, it is a lift. It is a lift. Lift is moving upwards with acceleration A. Lift is moving upwards with acceleration A. And
Break.
here we have the string and a block of mass m suspended. So from a lift, so a block is suspended with the help of ideal string. So inside the lift, a block is suspended with the help of a string. And the elevator is moving upwards with acceleration A. Lift is moving upwards with acceleration A. So find out tension force in the string. Find out tension force in the string. Find the tension force in the string. Listen, for example, here I'm drawing FBD. FBD for the block of mass M. I'm drawing FBD for the block of mass M. So if this is the object, what is the direction of tension force away from the object along the string? Away from the object along the string. Then after M is mass of the block, weight is mg. Weight is mg. And for example, a person is observing from the ground. A person is observing from the ground. Okay, so if lift is moving with acceleration A, lift is moving up with acceleration A. So for this person on the ground, this block also moving upwards with acceleration A. So why? Because lift is moving up with acceleration A. So this point of the lift is moving up with acceleration A. Now this point of the lift is connected to string. So string also moving up with acceleration A, moving up with acceleration A, moving up with acceleration A. So this point of this string also moving up with acceleration A. This point is connected to block. So if this point of this string is moving up with acceleration A, now this block also moving up with acceleration A. So it is a mechanism we have. So for this block, we have drawn FBD. And what is the direction of tension force away from the object along the string? So direction of tension force and gravitational force mg. So A is the acceleration direction of motion. Therefore, from this equation, what is the dynamic equation for this block? Dynamic equation. So the direction of motion upwards, that means we get T minus mg is the dynamic equation. Result into force, mass into acceleration. So ma, mass into acceleration equal to T minus mg. Therefore we have to find a T tension force. So T equal to mg plus ma. So minus mg becomes plus. So T equal to mg plus ma. Therefore T equal to, you take m common, so g plus a. Now it is the value of tension force in the string. So it is the next example. It is in the next example. Okay. Write down homework question. So it is lift. Inside the lift, a block of mass m, is suspended with the help of ideal string. So it is an ideal string, and this lift is moving downwards. Lift is moving downwards with acceleration a. Lift is moving downwards with acceleration a. So in this ideal string, tension force T. In this ideal string, tension force T. So in the question, it is given that mass of the block 5 kg, mass of the block 5 kg, acceleration, okay, this acceleration of the lift, 2 meter per second square, and take g value, acceleration due to gravity 10 meter per second square. Find out tension force in the string. Find the tension force in the string. So you try this question as a homework. Yeah, Siddhant, correct answer. Siddhant, 14 newtons. Not 16 newtons, Rahil, it is 14 newtons. Rahil, you try one more time. It's not 16 newtons, it is a 14 newtons. Okay. Okay. For example, it is a block of mass m. So for this block, for this object, if it is the object, direction of tension force away from the object along the string. Direction of tension force away from the object along the string. Then after, mass is m, weight mg, and what is the direction of motion? Downwards. Direction of motion downwards. Therefore, for this block, you write down the dynamic equation. So totally two forces T and mg, but direction of motion downwards, that means resultant force is mg minus T. Mg minus T. Resultant force means mass into acceleration. So mass into acceleration equal to mg minus T. We have to find the tension force, T equal to mg minus ma. So therefore T equal to m is a common, so g minus a, and you can simplify it. Mass is given, g is given, a is given, you simplify it. Write down next question. In the next question, this is the block of mass m1 string, and this is the block of mass m2. So m1, m2 connected by a string, and these are the smooth surface. So no frictional force at all. And in this question, this applied force is F2, and here on M1, it is the applied force. This applied force is F2, and this applied force is F1. So if this is the case, first of all, we have to find what is the condition, for the string to become taut. The condition we have to find out. Okay. So first of all, we have to find out what is the condition for the string to become taut, and what is the condition when the string becomes slackened. So what is the condition? What is the condition under which the string becomes taut and what is the condition under which the string becomes slackened. So let us see all the type of questions. For example, in this case, it is an ideal string. It is an ideal string and both the forces acting in the same direction. So both forces acting in the same direction. Now this acceleration, so it is an ideal string. So both are moving together with acceleration a. For example, I'm taking, so it is my assumption, both are moving together. Both are moving together with acceleration a. So how to find acceleration? You follow the short trick. You follow the short trick. Now how to find acceleration is resultant applied force upon sum of the masses. Resultant applied force upon sum of the masses. Resultant applied force, the two forces in the same direction. The two forces in the same direction. So what is the resultant applied force is F1 plus F2 upon sum of the masses is M1 plus M2. Now it is a value of result. So it is a value of acceleration, resultant applied force upon sum of the masses. So in this string tension force T, let us find out T value tension force. To find a tension force T, that's up to you. Taking M2 block or M1 block, that's up to you. To find a tension force, you take any one of the block, that's up to you. For example, I'm taking M2 block. For example, we are taking M2 block. On this M2 block, it is applied force F2. It is the direction of motion. Okay, applied force F2, direction of motion. For the block M2, it is the direction of tension force in the string. So on the block M2, the two forces acting in opposite direction and direction of motion. Therefore, I am writing resultant force dynamic equation. So therefore, resultant force equal to along the direction of motion, F2 is present. So F2 minus T. Resultant force means mass into acceleration. Resultant force, mass into acceleration. So mass M2, in the place of acceleration, I'm writing this value. So in the place of acceleration, we are writing F1 plus F2 upon M1 plus M2 equal to, on right hand side, F2 minus T. The question is, we have to find a T, tension force. So from this equation, I'm taking this negative value to left side and this positive value to right side. So what I'm getting here, T equal to, we have already F2 and this positive value to right hand side becomes negative. So a negative M2 in bracket F1 plus F2 upon M1 plus M2. So let us simplify it. By simplifying here, what we get, T equal to, so the LCM denominator is M1 plus M2. LCM denominator M1 plus M2, no numerator. To find numerator here, first of all, cross multiplication. First of all, this cross multiplication. This cross multiplication is M1 F2. This cross multiplication M1 F2 plus this cross multiplication M2 F2. M2 F2. Next, minus of this minus. So here you multiply with M2 individual. You multiply with M2 individual. What is the first multiplication is M2 F1. Next one is M2 F2. So we have taken LCM. So if we observe clearly, this M2 F2 minus M2 F2, they cancel out. M2 F2 minus M2 F2, they cancel out. Now after cancellation, we have tension force T equal to, so here we left with M1 F2 minus M2 F1. Okay, minus M2 F1. In denominator, M1 plus M2. Now this is the formula to find tension force in the string. Yeah, Rohan from Borivali branch, correct answer. Now we got tension force equal to, this is the formula. Yeah, what is the doubt, Ria?
Sir, I understood that both the objects will be moving in the same direction, so that's why their direction of motion is towards the right.
Correct.
But shouldn't we write acceleration different, like maybe one A1, another A2?
See. Still, the question is not completed. I have to do some cases. First, you complete writing this part. I will do the cases. I got your question. Okay, I will
Okay,
answer
sir.
it. First,
Okay,
write
sir.
down this part.
Okay, sir. Thank you.
So from this result, I'm taking first case.
Sir, can we use this formula every time for the tension force?
No. Don't take this formula as the basis.
Okay,
It is one question. It is one question. In this question, we got tension force.
Okay.
No need to memorize this formula. Okay. It is one application, and we got the answer. Let us see the consequences of this formula. Okay. First of all, here I'm taking case 1. You see the numerator. In the numerator, we have minus is present. Minus is present. So in the first case, I'm taking that if M1 F2, this M1 F2 is greater than M2 F1. For example, this M1 F2 is greater than M2 F1. If this is the case, now what is the tension force in the string becomes positive or negative or 0. This M1 F2, this positive value is greater than the negative value. If this is the case, now what is the tension force in the string? So tension force in the string becomes a positive. So tension force in the string is a positive. That means we can say string is taut. We can say string is a taut. So when tension force is a positive, when string is a taut, then the blocks they move together. The blocks they move together with same acceleration. A equal to, already we have the formula, resultant applied force upon sum of the masses. So the two blocks will move together with the same acceleration only under this condition. Only under this condition. If M1 F2 is greater than M2 F1, no, tension force becomes positive. Tension force positive means string becomes taut. String becomes a taut. When the string becomes a taut, or the two blocks they move together with the same acceleration A. So is the point clear?
Yes.
Now second case, if M1,
So one more, please wait.
okay.
So, sir, to find out that the two blocks are same acceleration, we have to calculate for both the blocks.
See, in the previous questions, no need to find out such a type of conditions. Why? Because in the previous cases, in the previous question, we have the two blocks are like this. It is one applied force, it is one applied force. Now these two applied forces will keep string taut or not?
Yes.
These two applied forces can keep string taut. So definitely in such type of questions, always string will be taut. The blocks they move together with the same acceleration. But in this case, so the two blocks in the same direction, the two forces in the same direction. If two forces in the same direction, can we give any assurance that string will be taut in all conditions?
No.
No, sir.
So those conditions we are finding out. So in what condition, the two blocks, they move together, they do not move together, those conditions we are writing. But in the previous question, is it compulsory to find out this type of questions, this type of conditions? No.
No, sir.
Sir.
Because it is known that the string is taut.
Okay, so in the previous question, definitely because of applied forces, these applied forces will create string becomes a taut. So it's not necessary in the previous questions. But in this question, compulsorily we have to find the conditions in which string becomes a taut and we have to find the conditions when string becomes slackened. Those conditions we have to write. Okay.
Sir, I understood that the string will be taught, but I'm sorry, but I'm unable to understand how the acceleration will be same for both the blocks.
If tension force will be same at all points, tension force will be same at all points. So at this point, okay, so at all points tension force will be same. You accept?
Yes, sir.
Okay. If it is moving with acceleration a, if it is moving with acceleration a, now this point of the block will move
Yes,
with how
yes.
much
Okay,
acceleration?
sir. Yeah. Okay, got it.
Okay, so it is taught means at every point tension of force will be same. So as a result, acceleration also will be same. Acceleration will be same. So this point also acceleration same. Got
Okay,
the
sir. Yes. Thank you, sir.
Okay, indirectly here, this case also nothing but this case also nothing but by rearranging this equation I'm writing here, it is F2 upon M2, F2 upon M2 is greater than, it is F1 upon M1. So both the conditions are same. Even though if we do cross multiplication, we get the same value. If we do cross multiplication, we get the same value. Okay. Write down second case. In second case, if M1 F2 equal to M2 F1, in the same way, M1 F2 less than M2 F1. I'm taking both cases, M1 F2 equal to M2 F1, or else this negative value I'm taking greater. Negative value M2 F1 I'm taking greater. If this is the case, what is the tension force? If this is the
Zero.
case,
Zero.
tension force 0. If this is the case, what is the tension force? Positive or negative? Negative. So generally here tension force 0 or negative tension force indicate the string becomes
Second.
slackened. In both cases. So when the string becomes a taut, when t value 0 or greater than 0?
Positive.
Greater than 0. When t greater than 0, only then string becomes a taut. If a t value 0 or t value negative, it means that string
Slackened.
slackened. If string is slackened, no, they move together. So string is slackened, no tension of force here. No tension of force here. No tension of force means indirectly there is no connection here. Correct? If no tension of force
Yes, sir.
means between M2 and M1, do we have any connection?
No, sir.
No.
If no connection means how the blocks they will be at rest or they move individually with a different acceleration.
Different acceleration.
With different action.
So what are the different accelerations then? So F2 by M2 is its acceleration. F2 by M2 is its acceleration. And F1 by M1 is its acceleration. So my question is clear. If this is the case or this is the case, string becomes slackened. When string becomes slackened means there is no indirectly there is no connection between M1 and M2. There is no connection between M1 and M2. If there is no connection means the two blocks they move together, they do not move together. If there is no connection, they do not move.
They do not move together.
That means how they are moving independently. Not together, they are moving independently. They are moving independently with the same acceleration or with a different acceleration.
Different acceleration.
Acceleration.
Then how to find its acceleration? Force applied
F2
upon
upon
mass.
M2.
Then how to find its acceleration is F1
F1
upon M1. Yeah, write down these points.
So sir, that will be A2 and this will be A1.
Correct. It will be A2, then it will be A1. Okay, if string is slackened. Okay, write down. When string is slackened, indirectly there is no connection. Indirectly, there is no connection between the blocks. There is no connection between the blocks. Then the blocks will move independently. The blocks will move independently with different accelerations. With different accelerations A1 and A2. Different accelerations A1 and A2. So how to find, therefore write down. Therefore A1 equal to, so how to find A1? So here there is no
F1 upon
tensional
M2.
force. There is no tensional force, only F1 is the applied force. So how to find A1? F1
F1
upon
upon M1.
M1. In the same way, so here there is no tensional force. No tensional force, then how to find acceleration A2 is F2 upon M2. F2 upon M2.
So,
Now please.
1 minute. So, if string is slackened,
Okay.
how can there be any tension force between them? Tension force can be zero, I understand, but negative,
Negative tension force means what?
which means
Reverse tightening or slackened case only. Negative tension force means what exactly what? String is a taut or string is a slackened?
Slackened.
That is only case. Tension force 0 or negative, it means that string is slackened. Okay.
so we can say that as string is slackened a little from being taut, tension force keeps on decreasing and at a point it becomes 0.
Okay, so here tension force negative means what exactly what you understand? You say tension force negative means what exactly you understand?
Which means tension force is decreasing.
How tension force decreasing or increasing? So we are applying, so constant forces or the variable forces we are applying?
Variable.
Variable forces. I'm giving F2 is a function of time, F1 is a function of time.
No, sorry, sir, constant forces.
So constant forces, but according to force and mass information, so what is the T value I'm getting?
Negative.
Or else still, if it is not clear, I have a question. You please answer. In this case, I'm taking, it is M2 F1, correct? M2 F1 is on the greater side, correct? M2 F1 is on the greater side than M1 F2. By rearranging this equation, we get F1 upon M1, F1 upon M1, F1 upon M1 is greater than F2 upon M2, F2 upon M2. So F1 upon M1 is its acceleration, okay? And F2 upon M2 is its acceleration. That means here A1 is greater acceleration, it is A1, and it is A2. So here A1 is greater than A2. A1 is greater than A2 means it is moving faster and comparative it is moving slower, correct?
Yes, sir.
If it is moving faster, it is moving slower, it leads string becomes taut or slackened. If it is moving faster,
Slackened.
the same thing I got it.
Okay, thank you, sir.
Okay, so if this is the case, I'm getting A1 is greater than A2. This A1 is greater. It is A1 is greater means this block is moving faster. If this block is moving faster than M2, so definitely string becomes slackened or becomes taut. If it is moving faster. Slackened. So obviously any case, if tension force 0 or tension force negative, obviously the ultimation, the point is string becomes slackened. Okay.
Thank you, sir.
Yeah.
T equals 0 or T negative means no tension force. We
No
should just
tension
straight
force.
away assume that.
Correct.
Okay.
So,
Please.
so practically T equal to negative is not possible, right?
Practically not possible. That means even though if we are getting T negative means what we have
Means
to
like
understand.
there's zero tension, right? Because like
Correct.
tension which is a force cannot be negative, right?
Correct.
Okay, sir. Thank you.
Yeah, right down. Next one. No, we will do some questions depending upon Lamis theorem. We will do some questions depending upon Lamis theorem. Okay, I already told you the Lamis theorem, the mathematical equation, all the points I explained you already in the previous classes. Okay. So again, a small revision. What is the Lamis theorem? For example, at a point, this is the force F1 acting. For example, it is the force F2 acting. It is the force F3 acting. So all the three forces acting at a point, and this point is at equilibrium. This point is at equilibrium. This angle, let it be theta 1, and this angle, let it be theta 2, and this angle, let it be theta 3. And in the last class already I told you the conditions when we have to apply Lamis theorem. So the whole content we completed in the last lecture. The only thing is the mathematical formula I want to explain briefly. So if all the conditions of Lamis theorem are applicable, then so what is the mathematical equation of Lamis theorem is first force F1. For the force F1, so what is the opposite angle theta 1? For force F1, opposite angle theta 1, so F1 upon sine theta 1 equal to, for the force F2, opposite angle theta 2, so F2 upon sine theta 2 equal to, so the next force F3, for the force F3, the opposite angle theta 3, so sine theta 3. So it is Lamis theorem we have. Yeah, write down. First question. Draw the figure. Okay, this block mass 7 kg, and in the question this angle is given 30 degrees. This angle is given 30 degrees. In this string, tension force T1 is given. In this string, tension force T1. In this string, tension force T2. In this string, tension force T2. In this string, tension force T3. So totally 3 strings. In this string, tension force T1. In this string, tension force T2. In this string, tension force T3. So in the question, this point is given at equilibrium. This point is at equilibrium. If this point is at equilibrium, find T1, T2, T3. If this point is at equilibrium, so find T1, T2, T3. Okay. So one thing is very basic question. It is at equilibrium. So this is T3 value. Okay. If I draw for this block free body diagram, it is 7 kg block. For 7 kg block, what is the direction of tension force? Is away from the object. T3. If this is the block, for this block I'm drawing the free body diagram. For this block, tension force away from the object. And a 7 kg block, its weight is 70 newtons. And you know how to find the weight mg and g value 10. Mg, mass into gravity value. So its weight 70 newton. So the total system is at equilibrium. So T3 value is equal to 70 newton. The total system is at equilibrium. So T3 value equal to 17 newton. So it is a very simple one. Then after I'm taking this tide point. For this tide point, left side. So you please refer what is the direction of tension force. I told you already, direction of tension force. It is always away from the object or always away from the tide point. Always away from the tide point along the string. If it is a tide point, what is the direction of tension force? Away from the tide point along the string. Okay, so it is the direction of T1. So what is the direction of tension force? Away from the tide point along the string. Then after, if it is the tide point, so how to draw T2 force? So T2 force is away from the tide point along the string. It is T2 tension force. Then after, so for this tide point, no, next tension force T3. And what is the direction of tension force? Away from the tide point along the string. Now these are the directions of T1, T2, T3 with respect to tide points. This is a tide point not necessary to consider. On this point we have to consider for the simplification of T1, T2, T3. Okay. So if this is 30 degrees, if you see clearly here, this angle 90 degrees. If this angle 90 degrees, so it is 90 degrees. Then after, if it is given 30 degrees, if this angle 30 degrees, this angle also 30 degrees. If it is equal to 30 degrees, this also equal to 30 degrees, and it is equal to 90 degrees. It is 90 degrees. So totally here between them, what is the total angle is 30 plus 90 is 120 degrees. Now this angle is 120 degrees. So it is 90 degrees, it is 120 degrees, the remaining angle is 150 degrees. Why? Because the total summation of all the angles should be equal to 360. Summation of all the angles should be equal to 360. So if it is 120 degrees, it is 90 degrees. Now this angle should be equal to 150 degrees. So for this tide point, it is a free body diagram. For this tide point, it is a free body diagram. Now let us apply. So it is a common tide point. Correct. Now let us apply Lami's theorem. Now we are applying Lami's theorem. First of all, I'm taking T1. For T1 tension force, what is the opposite angle? 120. For T1 tension force, opposite angle. So sine 120. Sine 120 equal to, next I'm taking T2 tension force. T2 tension force. For T2 tension force, what is the opposite angle? 90 degrees. So T2 upon sine 90 degrees equal to, the next one is T3. For T3 tension force, the opposite angle 150 degrees. So sine 150 degrees. So here we applied Lami's theorem. Let us simplify it. So T1 upon sine 120 degrees. Sine 120 is root 3 by 2. Sine 120 degrees root 3 by 2 equal to T2 upon sine 90 degrees equal to 1. equal to T3. Already we have T3 value, 17 newtons. So in the place of T3, I'm writing 17 newtons upon sine 150. Sine 150, the value is 1 by 2. The value 1 by 2. Therefore, from this equation, T1 upon root 3 by 2 equal to T2 equal to, so 2, it goes to numerator. 2 numerator. We get totally 140 newtons. Now from this equation, we have to find the T1 and the T2. T3 already we got it. And what is the T3 value? Already we have 70 newtons. Now the only thing is we have to find the T1 and the T2. So if we equate these two terms, then we have T2 equal to 140 newtons. Then after, now I want to find a T1. So if we equate these two terms, then what we have from this T1 upon root 3 by 2, T1 upon root 3 by 2 equal to 140. So root 3 by 2 you bring to right hand side. So therefore T1 equal to root 3 by 2 into 140. If we simplify, so T1 equal to 70 root 3 newtons. Now these are the values of T1, T2 and T3. So how did you get T1 is T3 70 Newton? You please refer the given figure. From the given figure, T3 is balanced by 70 newtons. Anushka, you see the given figure. The tension force T3 is balanced by the weight of the block 70 Newton. It's not given in the question, ma'am. You please refer the question. At least you see the question and try to get the question. If I say each and everything in detail, so still you people are not getting. So remaining people, T3 value already we done it and at the beginning of the question or not? Is a T3
Yes,
value?
sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
So Anushka, you please see, don't sleep, don't do any chat with others. You focus on the class. Once question is completed, you are asking how T3 is 17 newtons. Bullshit. Yeah, write down. Next question. For example, it is the tide point. So it is a homework question. You try. It is 10 kg block. It is 10 kg block. In the question, in this string, tension force T1, tension force T2, tension force T3, and this angle is given 60 degrees. Find T1, T2, T3 if the system is at equilibrium. System is at equilibrium means this block at equilibrium, tide point also at equilibrium. The whole system is at equilibrium. That means tide point at equilibrium, the block also at equilibrium. Okay, so find T1, T2, T3 if the whole system is at equilibrium. So can you try this question? You follow the same type of procedure what we had done in the previous question. You try. Okay. Yeah, write down. In Lam's theorem, one more example. I hope this also you will do it very easily. So these are the supports given in the question. It is a string, tied points, horizontal string, and here we have a block. W is the weight. W is the weight. So here T1 is a tension force in the string, and in the question this angle is given 30 degrees. This angle is given 30 degrees. So it is 30 degrees, it is 90 degrees, so totally 120. It is 30 degrees, it is 90 degrees, so totally 120. Okay, so this is tension force T1, this is tension force T2, this is tension force T3, but in the question this T2 tension force is given 13 newtons. This T2 tension force is given 13 newtons. We have to find a weight. We have to find a weight. So first of all, here I'm drawing FBD of W. This block free body diagram I'm drawing. So it is a W. For this W, it is the direction of tension force T3. For this weight, for this block or for this object, it is the direction of T3. What is the direction of tension force? Always away from the object along the string. Away from the object along the string. And weight W, and what is the direction of weight? Downwards. The weight direction downwards. I told you already, the whole system is at equilibrium. The whole system is at equilibrium means this block at equilibrium, this tied point also at equilibrium. This block at equilibrium. Equilibrium means forces are balanced. Equilibrium, forces are balanced. This T3 equal to W. So it is the first case. Then after, so I'm taking here this is a tied point. For this tied point, let us see the direction of tension forces. Okay, so for this tied point, it is the direction of T1 tension force. And what is the direction of tension force? We already discussed it. Tension force always away from the tied point, away from the tied point along the string. So it is T1. Then after, it is T2 away from the tied point. It is T2, and here away from the tied point. Away from the tied point is a T3. It is T3, and T3 value already we have W. This is T3 value already we have, that is W. And T2 value already given, it is 13 newtons. T2 already given 13 newtons. And here this angle is 90 degrees. Then after, it is 30 degrees, it is 90 degrees, so totally it is 120 degrees. This total angle is 120 degrees. Then this remaining angle is 150 degrees. Now the whole information we have, simply we have to apply Lamis theorem. If we apply Lamis theorem, first of all T1, for this T1 tension force, for this force the opposite angle 90 degrees. For this force opposite angle, so sine 90 degrees equal to, next I'm taking T2. So T2, for this T2 tension force opposite angle 150, so sine 150 degrees. Next equal to T3, for T3 tension force opposite angle 120, so sine 120 degrees. That implies T1. So we have sine 90 equal to 1. So T1 upon 1, simply T1. So T1 upon 1 is T1 equal to T2. And T2 already we have given 13 newtons. So T2 value already we have given 13 newtons upon sine 150 degrees is 1 by 2. Equal to T3 already we have W. So T3 value already we have W upon sine 120 degrees root 3 by 2. The question is we have to find a W. So you equate these two terms. Equate these two terms. Do simplification. Find a weight. Correct answer. Ria 30 root 3 correct answer. Ria correct answer. Devika correct answer 30 root 3. 30 root 3, not 3 root 3. Directly we are getting weight, and we have to find weight only. Okay, 30 root 3. Okay, same Lamis theorem. All these are very easy questions. Let us try one difficulty question. So in the next question, these are the supports. These are the supports we have given. Then after, it is a string. It is a tied point A, tied point A. And this block weight 10 kg. This block weight 10 kg. In this string, tension force is given T1. Then after, and here we have one more string, and in the question this angle is given 30 degrees. With vertical, the angle is given 30 degrees. Then after, it is another tied point B, another tied point B, and in the question it is given that in this string tension force T2, in this string tension force T1, in this string tension force T2, and then after here we have one more string. It is, so it is one more string. In this string tension force T3. Then after, with vertical, here we have another string. It is another string. In this string tension force T4, tension force T4, and in the question this angle is given 60 degrees. This angle is given 60 degrees. So generally, if we observe here, it is given 30 degrees. 30 degrees. If we extend, we're getting angle here 90 degrees. We're getting angle here 90 degrees. Now this is, it is one right angle triangle. In this triangle, total angle should be equal to 180 degrees. In this triangle, total angle should be 180 degrees. It is 30 degrees. It is 90 degrees. 90 plus 30, 120. So this angle 60 degrees. This angle 60 degrees. Now this is the question. It is one tied point. It is one tied point. So T1, T2, T3, T4. So 4 tension forces. The question is, if the whole system is at equilibrium, the whole system at equilibrium, find a T1, T2, T3, T4. So it is a question. So it is 10 kg, this mass 10 kg. So if the whole system is at equilibrium, write down the question. The whole system is at equilibrium. Find a T1, T2, T3, T4. So here, so in this string tension force, for example, T naught. In this string tension force, for example, T naught. But T naught, that is not necessary. Already automatically you please answer. The whole system is at equilibrium. That means the whole system at equilibrium. That means what is the value of T naught is?
100 kg.
100. So write down. So T naught already we have 100 newtons. Okay, T naught is 100 newtons. So first of all, I'm taking this tied point A. I'm taking. So the tied point A. For this point, let us draw FBD, free body diagram. So if this is the point A, so what is the direction of T1 away from the tied point? It is T1. Then after, if this is the point A, tied point, what is the direction of T naught? Direction of T naught, that is away from tied point. It is T naught. This value already we have 100 newtons. Now this angle is 90 degrees. Then after, for this tied point, it is a direction of tension force away from the tied point. Away from the tied point, it is T2. So in this case, this angle 30 degrees, this angle 90 degrees, it is 30, it is 90. So totally between T1 and T2, totally this angle becomes 120. This angle becomes 120, then automatically this angle becomes 150 degrees.
150.
So for tied point A, you apply Lamis theorem. If we apply Lamis theorem, so T1 upon sine 150, I'm writing directly sine 150 value 1 by 2. So T1 upon sine 150, sine 150 1 by 2 equal to T2 upon sine 90. So sine 90 value equal to 1. Next force 100 Newton. 100 Newton, so T naught 100 Newton. So for this T naught, opposite angle 120, sine 120 root 3 by 2. Sine 120 root 3 by 2. So therefore, from here, if we equate these two terms, now what is the value of T2 we get? By equating these two terms, what is the value of T2 we get?
200 upon root 3.
Perfect. 200 upon root 3 newtons. In the same way, if we equate these two terms, now 2 cancel out. 2 cancel out. Now what is the value of T1?
100 upon
3 newtons.
So 100 upon root 3 newtons. So that is a T1 value. So we got T1 value, T2 value. Still we have to find T3 and T4. To find T3 and T4, I'm taking tied point B. For this tied point, so here, so what is the direction of T4? Direction of T4 away from the tied point. It is the direction of T4 away from the tied point. For this tied point, what is the direction of T3 away from the tied point? It is the direction of T3. And what is the total angle? It is total angle 120 or 150. This already given 60 degrees and it is 90 degrees. Then what is the total angle?
150.
Now this angle becomes 150 degrees. Then after, if it is a B, for B, there's a T2 tension force present. For this B, T2 tension force present, and this is the direction of T2 tension force. Okay, away from the tied point, Now this angle 60 degrees. So it is 150, 60, 210. Perfect. Now this angle is 150 degrees. It is for the tied point B. Now you apply Lamis theorem for the tied point B. If we apply Lamis theorem, first of all, T2. For T2, you please answer. For T2, what is the opposite angle? T2, first of all, what is the opposite angle?
150 degree.
So what is the sine 150 value?
Half.
So T2 upon half equal to, next I'm taking T3. For T3, what is the opposite angle?
Half.
So 150 sine 150 is half. Perfect. Now equal to T4. For this T4, what is the opposite angle? 60. Sine 60 is 3 by 2.
Root 3 by 2.
So what is the T2 value already we have? In the place of T2,
200 by root 3.
200 by root 3 and 2, it goes to numerator. So totally becomes
400.
400. So this total value becomes 400 upon root 3. Then after, it is nothing but 2 T3, and this is nothing but 2 T4
4 is
upon.
200.
So by equating both the terms, now what is the value of T3 we get by equating both? what is the T3 value?
200 upon
200
root
upon root 3.
200 upon
100 upon
root 3.
root 3 newtons. In the same way, if we equate both root 3 cancel out and 2 cancel out, then what is the T4 value we have?
200.
200 newtons.
200 newtons. So it is about Lami's theorem. Is it clear?
Yes, sir.
Yes, sir.
Okay, so
Yes, sir.
Thank you, sir.
in the next lecture, we will do constraint motion. So for the laws of motion chapter, constraint motion is very, very important. In constraint motion, we study about the pulleys. Okay, we have so many concepts are there. Okay, so we
Okay,
discuss
sir.
in the next lecture. Okay,
Thank you, sir.
thank you.
Thank
Bye.
you, sir. Bye, sir.
Bye bye. Take care.
Sir, I have a doubt in the homework question. Last class.
I have one more class now. Okay, you please
Okay,
send
sir. Can I ask on the group?
you please send me personally.
Okay, sir. Personal.
Sir,
Please.
sir, this is Anushka. Sorry for disturbing
You know,
you, but I
I'm
have
also
got disconnected only.
so
sir.
generally I have to say sorry also. Okay, I have to say sorry.
Sir,
Okay.
it's
Why?
alright.
Because
But I
generally
just got disconnected. That is why I asked it out. I was paying attention, sir.
okay, sorry. From my side also,
No problem.
sorry. Okay.
Yeah, sorry, sir. Thank you.
So,
Please.
so would you send the module of the laws of motion chapter?
I think you got the module now from PACE. You got mains
Yeah.
booklet, correct?
Yes, sir.
Okay. You practice the questions from the mains booklet. In this meantime, I will send you advanced also. Okay.
Okay, sir. Okay, sir.
Definitely, I will send you advanced also.
Okay, sir.
Thank you, sir.
Yeah, bye.